So we continue with the vector triangle law. Now, vector triangle law is the most important law in vectors because everything in vector hereafter, or most of the stuff in vector hereafter, is going to use the vector triangle law. We'll see the vector triangle law in the parallelogram law of vectors. We'll see that in vector geometry. So if you don't know the vector triangle law, you're going to have some difficulty solving questions in vectors hereafter. So when two vectors are going in the same direction, we complete a triangle with a vector going in the opposite direction. The vector going in the opposite direction is called the resultant vector. The resultant vector is equal to the sum of the other two vectors. So the question is, are these two vectors going in the same direction? It may look like the one is going up. According to what we learned, one is going up and one is going down. So it looks like they're going in different direction. But when they are connected like that, they are going in the same direction. Because you can see if you're trying to move, if you are moving up here, you will notice that you're going with the arrow. Come around this corner, you're still going with the arrow. So you're going in the same direction. If you're going to the same place. So to get a resultant vector, we have to get a vector going in the opposite direction. And this will be the resultant vector here. Because if we go again, if we're going up, we're going with the arrow, we're going with the arrow, we come around the corner here, we're still going with the arrow. When you come around this corner, you'll be going against the arrow because the arrow is pointing in the other direction. So AC, the one that is going in the opposite direction, is called the resultant vector. The resultant vector, and this is the most important part of the statement, the resultant vector is equal to the sum means to add, of the other two vectors, BC. So when two vectors are going in the same direction, we complete a triangle with a vector going in the opposite direction. This is this one here. The vector going in the opposite direction is known as a resultant vector. The resultant vector is equal to the sum of the other two vectors. So here we have vectors going in opposite direction, or vectors going in same direction. So we have to complete a triangle with a vector going in the opposite direction. So which one will be the resultant vector for the triangle KLJ? Which one should go in the opposite direction? That one would be from K to J. The vector from K to J. So KJ is the resultant vector. So KJ must equal to the sum of the other two vectors, KL and LG. Alright? Okay, so let's see. Let's see that and let's prove that by observing. The vector KL is 4 because it starts at 0, 1, 2, 3, 4 on the x-axis. You can do ending point minus starting point for the vector KL, and your KL is equal to L minus K. L is 4 and 3, 4 and 3, minus K is 0, 0 and 1, 0 and 1. So KL is 4 and 2. Now what KL is, and LJ now. LJ is J minus L, ending point minus starting point. J is 7 and 2, so 7 and 2 minus L is 4 and 3, 4 and 3. So the vector LJ is, when you subtract there, 4 minus 2 is minus 2, which means it's, 7 and, 7, this is 7. L is 4 and I have this backwards. This is 7. J is 7 and 2 and 2, right? 7 and 2. So this is 4, 7 minus 4. 7 minus 4 is 3, positive 3. And the bottom is 2 minus 3 is minus 1. And you can see that the vector went down 1 and went across to the positive side of the x-axis 3. So we have our two vectors. So the vector, coming back to the vector triangle law, kj has to be equal to the sum of the other two vectors. So kl is 4 and 3 plus lj is 3 and minus 1. Right, 3 and minus 1. I think something is wrong there. This vector is KL is not, is 2. 3 minus 1 is 2. I put back my mistake. I put a 3 there. And the reason why I noticed that is because I observed it, that this is 2 and not 3. And the answer, I observed the answer KL to be, the y value should be 1 and not 3 minus 1, 2. So 4 plus 3 is 7 and 2 minus 1 is 1. Right. This value here is 1. Good. So, and also, if you wanted to find kj, the resultant vector, we can still do the ending point minus starting point. It works everywhere on the Cartesian plane. This is 7 and 2 minus k is 0 and 1. 7 minus 0 is 7, 2 minus 1 is 1. So we can use the ending point minus starting point. And we can also use the vector triangle law. When two vectors are going in the same direction, the resultant vector is equal to the sum of the other two vectors. Okay, so we have some others here. I'm going to do one more. You can do this one. I think I'm going to do this one. The vector, the triangle EFG. So which one will be the resultant vector is the question. We have EG and GF going in the same direction. So obviously this one has to go in the opposite direction. And if you can't figure it out, run your finger on the thing. This one is going with the arrow, going with the arrow, going with the arrow, going with the arrow, going against the arrow. So the one that is going against the arrow, which is EG, EF is equal to the sum of the other two, EG plus GF. So from observation, I can see that EG is 3 on the x-axis minus 3 on the x-axis and positive 2 on the y-axis. I can see that GF is minus 2 on the x-axis and minus 3 on the y-axis. You can do that too. 7 to 4 is 3. It's going towards that side, so it has to be negative. 3 to 1 is positive 2. Good, because it's going up. For this one, 4 to 2 is 2 minus 2 because it's going towards the negative side of the x-axis. And 1 to 4 is 3. It's going down, so it's a minus 3. So the vector EF is minus 5 and 1. Minus 1. Minus 5 and minus 1. And you can use again ending point minus starting point. So you don't have to do the vector triangle. All this just shows you if they ask you to calculate a vector, the resultant vector, you can use the ending point minus starting point to avoid all of this. This is used mostly in vector geometry. So EF the vector EF, the resultant vector EF is equal to ending point, ends at F minus starts at E. So F, the position of F is, the coordinates of F is 2 and minus 4, 2 minus 4, minus E is 7 and minus 3, 7 and minus 3. So let's get this. 2 minus 7 is minus 5, and minus 4 minus minus 3, these two become positive, minus 1. And that's how you do the vector triangle law. Good. This is the guy that you have to worry about in your examination. The parallelogram law of vectors. I've seen this a lot. And mostly they normally ask to complete a parallelogram. So this one says when two vectors are going in different direction, we complete a parallelogram to obtain the resultant vector. Right, so how do we complete this parallelogram? There's some trick to it. Very easy stuff. So a parallelogram, the property of a parallelogram is that opposite sides are parallel and equal in length. For this parallelogram here, the side AB has to be parallel to the side. We don't see the D here, but we know the D has to be somewhere out there. The side AB has to be parallel to this opposite and parallel to the side CD. So and it has to be an equal vectors as we did before. It has to lean the same way. It has to have the same magnitude and it's going in the same direction. So this side must equal to that side. So let's say it goes like that. That looks parallel and equal in length. And this side at the bottom here, the vector BC, must be parallel and equal in length to AD. So that's my parallelogram. I complete my parallelogram. Now, my resultant vector is this, BD. That's how we obtain the result. That's why we obtain the resultant vector by completing the parallelogram. We have to get this one. And why do we have to get this one? It goes back to the vector triangle law. As I said, a lot of things revolve around the vector triangle law. How can you see that? When two vectors are going in the same direction, and that is a standard for resultant vector. When two vectors are going in the same direction, this you can see BC going to CD. The vector that is against is the resultant vector. So we somewhat exclude half of the parallelogram to obtain the resultant vector, either the bottom half or the top half. BC, BA, AD, same direction, coming around this side, opposite direction. So for any one of the triangles, the resultant vector is BD. Now, why didn't you just obtain a resultant vector by drawing this line here? By this line down here. Draw across the line there. That's not the resultant vector. Because you draw this line here, right? If you are drawing that line there, let me do a sketch of this side here, right? Two vectors going in opposite direction, right? If you connect this line there, going down there, it cannot be the resultant vector because it is not going, say that again, cannot be the resultant vector because it's going in the same direction as one of the other vector. And the statement for resultant vector is the one going in the opposite direction is called the resultant vector. So you just can't connect one and say that's the resultant vector. It has to be going opposite to two other vectors. And that's why the resultant vector is the one that's going down is one of the diagonals, this diagonal of the parallelogram. So we have a parallelogram here. Determine the resultant vector of parallelogram, should be parallelogram PQRS. PQRS, right? Parallelogram PQRS. Good. So how do we obtain the resultant vector? There's two ways of doing it. You can observe or you can calculate. For the examination purposes, you have to calculate. So I know for sure S has to be somewhere out here. I don't know where for sure, but I know it has to be somewhere out there. I also know that the side the side QP is equal to the side RS. That's a fact. Because you see about parallelogram, the property of a parallelogram is that opposite sides, as I said up here, are parallel and equal in length. So AB or BA must be equal to CD. BA is equal to CD and BC is equal to AD because they are parallel and they have to be equal in length. They are equal vectors. So this vector here is equal to that vector over there. Parallel, equal in length. So if we know what the vector QP is, we can find the coordinate for S. Let's see. Can we find QP? QP. We have to show this in your calculation in the examination if it comes to that, right? QP is equal to P minus Q, ending point minus starting point. P is 3 and 4, 3 and 4, minus Q is 1 and 1. So the vector is 2 and 3. The vector QP is 2 and 3. So QP, 2 and 3 is equal to RS. We don't know what RS is. We know that it's 2 and 3, but we don't know what the coordinate of S is. This is what we did before, trying to find the ending point of a vector. So, but we know the coordinate of R. RS is the vector S minus R. We know the coordinate of R. R is at 6 and 1. So 2 and 3 is equal to, we don't know what S is, but we know R is 6 and 1. Coming up here. If we take the 6 and 1 over, we have 2 and 3 plus 6 and 1 equal to S. So we're going to find the coordinate of X when we add these two. This is 8 and 4. 8 and 4. Okay? Well, let's see if that will form a parallelogram. 8 here, 4 here. So it completed the parallelogram. You could have used the vector at the bottom here also, which would be 5 and 0. 5 on the x-axis, it didn't cover any y distance, so it's going to be 0 on the y-axis. So you could say that QR is equal to PS, and the same like we did here, QR is equal to PS. We said QR is 6 and 0, and we need to find, and PS, the vector PS is S minus P, ending point minus starting point. So 6 and 0, we know what P is. P is 3 and 4. Right? When we take this 3 and 4 over, 6 and 0 plus 3 and 4. Did I make a mistake somewhere? The vector is 5, not 6. The vector QR is 5, 0. Sorry about that mistake, because I'm observing again as I'm calculating. I'm just calculating blindly, and you have to do that in the exam too. You don't calculate blindly, you observe as you calculate. So 5 plus 3 is 8, 0 plus 4 is 4. So the ending point S is 8 and 4. You could have chosen any one of the two vectors because they are parallel and equal in length. So we still haven't obtained the resultant vector. The resultant vector is QS. This vector here. As over here, we can obtain this resultant vector by adding the two vectors. And let's do that on the, don't worry the confusion on the page, right? I'm going to do it here and I'm going to do it there again. So the resultant vector, we know that the resultant vector QS is equal to the sum of the other two vectors. I'm using a bottom triangle. You can use the top one. QR plus RS. Good. So QR we said just now is 5 and 0. RS we said earlier is 2 and 3. 5 plus 2 is 7. And 0 plus 3 is 3. So, how can we get the resultant vector again? QS, you know, there's two ways of doing it. We can use the vector triangle law, or we can use ending point minus starting point. This will be S minus Q. S minus Q. So S is 8 and 4. 8 and 4 minus the Q is 1 and 1. 8 minus 4 is 7. 4 minus 1 is 3. So that is your resultant vector. Okay, so the other trick I was to show you is if you look at how this vector is lean. See how the vector leans? It starts here and it leans and end there. Starts at 1, leans and end at 2. So if this vector starts here, it has to lean and end at 2. So that's how you could, another way you could have figured out where the S point is. It had to lean and end at 8. It doesn't lean for this vector, so we don't have to try to get for Y. So the vector, the ending point would have been for S would have been 8 because of what lean and 4. Let me show you a different example over here. And this one is a bit more complicated because it leans for the Y and it leans for the X. So my video is going a bit too long, so I will stop in a while. So we can do all the calculations we did just now for this one. We're doing all the calculations over here. Determine the resultant vector for the parallelogram ABCD. So D has to be somewhere out here. We don't know where D is. So, but watch how I'm doing this thing now. This vector starts at A, right? Starts at 1 and leans towards 2. Let me get a pencil instead of the pen. Starts at 1 and leans towards 2. So this vector here, which is, we know that the vector AB has to be parallel to this one somewhere there. Good. If it starts at 1, it has to lean towards 6. This one starts at 1, leans towards 2. It leans 1. This one starts at 5, it has to lean towards 1. One vector has to move from 1 point to 1 point, from 1 to 2, from 5 to 6. That's how the vector lean and move. So this vector has to stop somewhere at 6. Next one, for the vector at the bottom now, it starts here and it ends here. It starts here, ends here. It went up 1. You can see it elevated or it leaned up 1. So if it starts at B, it has to lean up 1. It has to end up here. It starts there, it has to end here. Start there, has to end there. Start there, has to end here. So it has to end here at 2. So the resultant vector is now, without any calculation, there and there. The resultant vector is somewhere from here to there. All because I watched all the two ends of the two vectors are going in the different direction. I watched how it was lean, and I leaned the one that is parallel to it. I lean the one that is this one that is parallel to that one, and I lean this one that is parallel to that one. I followed the pattern. But please do the calculations for that. The vector AB is equal to CD. And if AB is 1 and 1 on the x-axis, 0, 1, 2, 3. AB is 1 and 3. And this is D minus C. We don't know what D is, but we know what C is. 1 and 3 is equal to D minus C is 5 and minus 1. 5 and minus 1. you may wonder where I got the 1 and 3 from. It's not the position, it's not the 1 on the x-axis and 3 on the y-axis. It's the vector here. Vector, it starts here, 0 to 1 to 2, 0, 1. 1 to 2 is, or we can do ending point minus starting point for that. AB is B minus A. B is 2 and 1 minus 1 and minus 2. 2 minus 1. 2 minus 1 is 1. 1 minus minus 2 is 3. So that's how we get the 1, 3. It's the vector we're using. We're using the idea of the parallel vectors to find the coordinate of the ending point for the other one that is parallel to it. So this comes over 1, 3 plus 5 and minus 1 is equal to D. This is 6 and 2. So the coordinate of D, we use the vectors that are equal to find the coordinate of one side. Coordinate of D is 6 and 2, as we did it here. Try this one too, do this one here, make sure you get a good look at it. And the next video will be position vectors.